Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at change of base formula or formulas for logarithmic expressions. So let's go ahead and get started. Now, a very common problem, especially if you're using a calculator, is to try to deal with calculating different values with logarithms when the logarithm is not base 10 or the natural logarithm. This is a huge headache because many calculators do not have the ability to deal with this. So for example, I hope you can see this. Let's say I want to do log sub base 3 9. Now I know the answer is 2, but you see I get these error messages, and I try to do log and then 3 times in the 9 like this, and I get 4.2, which is completely wrong, because essentially what's happening is that the calculator is doing the log of 3. I can show you right now, and is multiplying it by 9. That's why I get that crazy answer of 4.29. So it doesn't work. Many times, depending on the calculator, you're probably going to have issues with this. And so before you can use your calculator, again, this is assuming you're not using an internet resource. Of course, if you find an internet resource, it can deal with different bases. But if you're using a regular calculator, a lot of times you're going to have challenges dealing with bases that are not 10 or that are not a natural logarithm. And so of course, there's a formula for everything in mathematics, and there's a way to deal with that by using the change of base formula. So this is what we're going to try to talk about in this video. So the formula is as follows: log base a with an argument of m equals the following: log base b, that's the new base, whatever you want it, with the argument of m, over log base b with a. So what happens basically is this. Let me just draw a picture, draw little arrows here. The m continues to be an argument like so, but the a that used to be the base, it now becomes what we often call an argument, and then you have the new base that they have in common like so. And so this is how you're able to deal with changing the base so that you can accomplish different things. Now let's do an example. Imagine we have the following. We got log base. Oh wait, there's one more thing I need to explain to you before I do that. So let me go back. Sorry, I forgot. So one more thing that I need to mention is that when you have base 10, let's take base 10 as an example. So I want to convert something to base 10. Oh, wrong color. Base 10. And so here's what it would look like. So I got my original log base a, m, and that's going to equal the following: log base 10 multiplied by the m argument, by argument of m, and log base 10 with a here. Now you guys know that we normally don't put 10 when that's the base because it's very common, but this is what it would look like. And of course, if we're dealing with the natural logarithm, so if our base is going to be e, Euler, it'll just be as follows: log base a argument m is going to equal the natural logarithm of m over the natural logarithm of a. That's it. So those are the things I want to touch. Because we commonly convert to base 10. Of course, there's exceptions to that, but most of the time we convert to base 10. Now let's go through our example. I forgot to, after I cover those things, I forgot. So log base 3 with the argument of 42, that's going to equal the following. Is going to equal log 42. Now I'm going to put the 10 just to complete the thought. Let me change colors here. So log base 10. Remember, you don't need the 10, but I'm going to put it there to complete the thought. For those who are new to this, multiplied by log base 10 with the argument of 3. And so that's going to be our answer. Or if we want to do, let's see here. If we want to do natural logarithm, so we go from log base 3 to 42 times the 42. We're going to do now is going to be the natural logarithm of 42 over the natural logarithm of 3. And so in this situation, it's not that hard what to do. You just deal with them accordingly, and you can get the answer. So we're going to go ahead and use the calculator for this, for sake of simplicity. So here we go. We got log 42 divided by log 3. And you can see right there the answer is 3.402. Now, if we really did this right, if we use a natural logarithm, excuse me, let me put that over here. Oh, there's no place to put it. How about down here? Okay, well, I'm going to do the natural logarithm now. So if I go back here and I change this to an ln, because that's how, ln, that's how it works. Let's see right there. And you can see I get the exact same answer, which indicates to me that the change of base formula worked. So I'm going to go ahead and move that out the way. Whoa. So you can see that in either case, the answer is 3.402, like so. Let's do one more, shall we? Now this time we're going to have log base 5 with an argument of 46. And so whether we do natural or whether we do the common or base 10, whatever you want to call it, is going to be as follows. Log base 10. I'm just writing the 10 for those who are new to this. You don't have to put that, just to complete the thought. And log base 10 with the argument of 5. Or another way to write that would be the natural logarithm of 46 over the natural logarithm of 5. Either one. And if you calculate this one, I did that in advance. You can check it yourself. You should get about 2.37, like so. And so, now we have the answer here. So you can see that this is very, very convenient when you want to check your answers when you're dealing with natural logarithms or base 10 or whenever you have unusual bases or whatever. Understanding the change of formula for logarithmic expressions will allow you to be able to check your answer in a traditional standard calculator that may not be able to handle various bases, which most of the time they cannot, because I guess they're assuming that you'll know the change of base formula, so they didn't put the function in there, if you will. So that pretty much concludes this video. Let me repeat what we talked about and conclude, and then we'll wrap up this video. So in this video, we took a look at how to change the base of a logarithm. And this is very, very important for when you want to calculate your answers or whatever. So basically all that you essentially do is that you take the base of the original logarithm and that becomes an argument here. And then you take the argument in the original logarithm and it becomes an argument here above in the numerator. And then you have your log again, and whatever base you want, you just put it there as appropriate. And that is how you're able to change the base and still get proper correct answers. And so if you're normally most of the time we change to base 10 or we change to the natural logarithm. And so here's kind of what it looks like. We have our log AM. Right here, my 10 is my B. That's why that's here, like so. And then you can see I move my A to be an argument, my M stay the argument, and we just divide them by each other. That's it. And then, of course, for base E, you can see right here, there's a natural logarithm, which, of course, you don't have to put the E because that's why you have the ln, and it works very, very well. And so then we went through some examples. Again, this is not deep, computation, but you just have to be familiar with the various processes that are involved in these particular exercise. So I hope this was useful for you. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.